This channel, and in this video I'm going to be looking at the quadratic theory part 2, where we're focusing on the discriminant and how we could be able to use the discriminant to be able to determine the nature of the roots of a quadratic equation, right? So first of all, understanding that this is the general form ax squared plus bx plus c equal to 0, and to solve a quadratic equation using the quadratic formula, we have that x is equal to negative b plus or minus the square root of b squared negative 4ac over 2a, right? So this topic is essential for maths 101, right? So an important stuff here is that understanding the formula, you won't have a problem with this, because looking at what you have here now, which is b squared negative 4ac, right? It's a huge determinant of what the roots are going to look like, right? So if b squared negative 4ac is equal to 0, let's assume that b squared negative 4ac is equal to 0. So on substituting in the equation, we're going to have negative b plus or minus square root of 0 over what? 2a, which will be what? Negative b over what? 2a. So you will notice that you're going to have repeated roots. So note, if b squared negative 4ac is equal to 0, the equation has real and equal roots, right? It has real and equal roots, or you could say it has repeated roots, or you could say coincident roots, right? So when you substitute for b squared negative 4ac for a given quadratic equation and then you're getting 0, it implies that that equation has equal roots, just like in the case of x squared negative 6x plus 9 equal to 0. If you want to solve this using a quadratic formula, all you have is be negative 6 plus or negative square root of what? Negative 6 squared negative 4 into what? A, which is 1, into c, which is what? 9, all over what? 2 times 1, that's 2a. Negative 6 is plus 6 plus or negative square root of negative 6 all squared is 36, negative 4 times 9 is what? 36 over 2, right? So that will be 6 plus or negative 0, right? Because 36 negative 36 is what? 0, and then over 2, and then you have 3. That's why at the end of the day, you have 3 twice as the solution. That means it has repeated roots, or we say it has equal roots, or we can say it has coincident roots. So that's why when we are using the factorization method, we'll have x squared negative 3x plus 9 equal to 0, which leaves us with x into x negative 3 minus 3 into x negative 3 equal to 0, and then we'll have that x negative 3 into x negative 3 is equal to what? 0. So you can notice that it has repeated roots. Do you understand? So now, another important stuff here is that if b squared negative 4ac is less than 0, then the equation has imaginary roots. Why is that so? So that you don't forget or you don't confuse it, right? So from the general equation that says that negative b plus or negative b squared negative 4ac over 2a is equal to the x values that will satisfy biggest. So if b squared negative 4ac is less than 0, that means we will now have to start finding the square root of what? A negative number, right? The square root of a negative number, which is what? Complex. So that is an indication that the equation will have what? Imaginary roots, right? Or you could call them complex roots. Do you understand? So imaginary roots, or you could say complex roots, if b squared negative 4ac is what? is less than 0. Now, if b squared negative 4ac is greater than 0, then the equation has real and distinct roots. Why is that so? Because negative b plus or negative square root of b squared negative 4ac over 2a is such that if b squared negative 4ac is greater than 0, the square root of a positive number exists, right? And it's going to make it distinct. Just like the case of x squared negative 6x plus 8 equal to 0. Right? If we solve it, what are we going to have? Negative 6 plus or minus the square root of negative 6 squared minus 4 into 1 into 8 all over 2 into 1. And that will be negative 6 plus or negative the square root of 36 minus 32, which is what? That's over 2. And then, which leaves us with negative 6 plus or minus the square root of 4 over what? 2. So that'll be negative 6. You get? So that'll be negative 6 plus or negative 2 over what? 2. So you can now notice that you will now have negative 6 plus 2 over 2. And negative 6 plus 2 is what? Negative 4. Right? It's going to be negative 4 over 2 or what? Negative 8 over 2, because negative 6 negative 2 is what? Negative 8. So negative 4 divided by 2 is negative 2, and negative 8 divided by 2 is negative 4. So you can see that the solutions to the equation, they are what? They are real, right? And another thing is that they are distinct. Do you grab? So when b squared negative 4ac is greater than 0, it implies that it has what? Real and distinct roots. If b squared minus 4ac is equal to 0, it implies that it has real and equal roots. And then if b squared negative 4ac is less than 0, then we could say it has imaginary, or we could say it has imaginary and distinct roots, because for sure the roots will be imaginary, the roots will be distinct, right? So let's take some questions. And from what you've taught, I would want you to attempt it yourself, right? So if I give you this equation now, 3x squared negative 7x plus 6 equal to 0, and I should ask you, describe the nature of the roots of the equation. Without much wasting time, how that we done? You simply evaluate what? B squared minus 4ac, right? And in this case, b is what? Negative 7, right? And now we negative 7 squared minus 4 into a, which is 3, into 6, which is c. And that will be negative 7 all squared. Negative times negative is positive. And then we now have 49 minus 4 times 3 is 12. 12 times 6 is what? 72. And 49 minus 72 is what? 72 minus 49 is what? That will be 3. That will be negative 23. So since b squared negative 4ac is less than 0, what does that imply? It has what? Imaginary roots. Or you could say what? Imaginary distinct roots. Do you grab? So that's it. So now, do this on your own. No? Pause the video and attempt it. So if you're given this question now, x squared minus 8x plus 16 equal to 0. Can you describe the nature of the roots of this equation? What's that? It's what? B squared negative 4ac. And that'll be what? Negative 8 squared minus 4 into 1 into 16, right? So that'll be negative 8 squared is 64 minus 4 times 16, that's still 64. 64 minus 64 is what? 0. So what does that imply? It has real and equal roots. Now, attempt this one. X squared minus 6x plus 11 equal to 0. What kind of roots does it have? Can you describe it? B squared negative 4ac will be what? Negative 6 squared negative 4 into what? 1 into 11, right? So that will be 36 minus 4 times 1, 4 times 11, that will be what? 44. And 36 minus 44 is negative 8, right? So what does that tell you? Imaginary roots, or you could say imaginary and distinct. So once b squared negative 4ac is less than 0, you can infer that it has what? Imaginary roots. So now do this one. That's our last question for this video. So if you are given this now, 7x squared minus 16x plus 13 equal to 0. Can you describe the nature of the roots in 10 seconds? What's that going to be? Pause the video and attempt it, please. Pause. Have you paused? Okay, so that's b squared negative 4ac equal to 0. Sorry, b squared negative 4ac is going to be giving us negative 16 all squared negative 4 into 7 into 13, and negative 16 squared, negative will cancel negative. 16 squared is 256, right? 4 times 7 is 28, and 28 times 13 leaves us with 4, 2, 3 times 2, 6, plus 2, 8, and that's 1 times 8, 8, and then that's 2, and then that's 4, then 6, then that's 364. So 256 negative 364 is what? You can write as 364 minus 256, which is leaving us with 8, and then this is 35, and then this is 0, and then this is 1, right? So that's negative 108. So this is the discriminant, right? In case if you're asked what's the discriminant, this is the discriminant, which is b squared negative 4ac, right? So since this value is less than 0, what can we say? Imaginary distinct roots, or if you just say imaginary roots, it's fine. Do you understand? So that describes the nature of the roots of this equation. Thank you so much for watching this video, right? Thanks for coming again. Or if this is your first time, please do well to subscribe to this channel by clicking on the subscribe button. It's free of charge. Like and share this video, and if you've been here and you've not subscribed, please do well to subscribe. And thank you so much guys for watching. Have a nice day.